Good day to you. This is Anagalactic. On the 15th day of April, we're now going to conjugate infinity in order to get the reference frame for the universe. This will solve all the problems in mathematics and physics. The first word we want to define is infinity. When you do so, you use my bootstrap theorem, which is the initiator for my discovery sequence. So this is right ab ovo from the beginning, tabula rasa. You know nothing about space, you know nothing about anything. I'm going to tell you everything. I'm Euclid. Okay. Infinity is composed on the line first. That's how you grasp infinity. It's not mathematical infinity, it's not time infinity. We're going to get to that and we're going to solve everything. We'll get the definition of time, we'll get the definition of everything. But you're not going to get anywhere until you have the definition of infinity, for which you need the line. So the bootstrap theorem begins by saying the line has two infinities that add to zero. That makes sense. When you take the next step in the bootstrap theorem, you draw the same line, but as you make the radius, actually the diameter, because you're going in two directions, so two radii going in opposite directions, to make two polar infinities, which defines the line all the way to infinity. You can now say, hypostatically, that the line has two endpoints, beyond which is infinity. So that's the end point of the line that defines a finite space, in this case for the circle. So you draw the line, and as you draw the line, it makes a circle. So they're absolutely mathematically related, and that you know is true. So you're drawing a circle at the same time you draw a line. That actually is a way of parameterizing the plane on the circle, capturing all of linear geometry and losing nothing. That's a miracle. So I discovered this. This is a great blessing to you to be able to tune into this right now, so pay attention. So when you have a line with two infinities, they're polar infinities using add, because that's the only operator on the line. And so the two infinities add to the center. Now, what does that do to the circle? It makes it the surface of the plane. And that means that it's the boundary of an infinite plane. So the circle we just drew to linear infinity is also circular infinity. And that's the union of linear infinity with circular infinity on a constant. Technically called 2 pi in linear numbers, we're now going to change that and say that that's 1. And that makes the radius the inverse of tau. So that all makes sense so far, and now we enter the bootstrap sequence, which has to do with the circle, not the line. We can forget about the line because we've captured it completely. It's inside the circle. So the circle has a diameter that is the line that goes to the infinities. Therefore, the circle is the conjugation of those two infinities. But you can't use add because the circle isn't a line. The circle is actually a division, and that's inaccurate, so I'll say it right as a proportion, which we write as a fraction, which we're taught in school inaccurately as division. Forget division and multiplication. We're going to define what those are now. They've never been defined before. What is division? It's 1 over 1. That's the simplest form of division. And now you've got to drop that word. It's not dividing anything. I'll show you where we got the idea that that's division. Multiplication and division are retarded terms that have poisoned your mind. That's profound, but I am a profound discoverer, so if you're going to get this, you're going to have to go along with me. That's called the hypothetical step, where you spill the beans. This is what I'm going to prove. Everybody rolls their head. Most people walk away. Some people throw tomatoes. That's what it's like to make a major discovery. I'm all set for that, so let's go. We have now a circle outside of which is imaginary space, inside of which is real space, physical space, projected down to a circle. But this represents a sphere, as I've proved, so now you know we're actually looking at the projection of a sphere down to a flat surface, which is how we see. So this matches everything we know about reality and consciousness. So this is the right answer so far. Can I prove the definition of infinity? We're going to do so now. This is going to be easy. I hope you like this, because if you don't, it's probably because you didn't listen. So listen carefully. We now have captured linear infinity. And the way we did that is by drawing a circle at the same time as we draw the line to infinity. So where the line stops is the derivative of the circle. It's smaller. It's smaller by a linear quantity of about 6 1/4 to 1, because tau is 6.28 dot dot dot. It's 2 pi. That's what tau is. I use the word tau because that's correct, and you should never say 2 pi. So this is really a revolution in science at every level. I've got the right answer, so you're going to have to conform to what I say, because I will say it right when nobody else will. So the conjugation of two linear infinities gives us the definition of add, and that's the only purpose of add, and now we can forget add. Universal space does not use the addition operation. You can use it in the derivative space, which is fully recoverable from circular space, which is the planar definition of spherical space, which defines the universe. So we need the universal reference frame. We're shifting from 0 to 1 proportion 1, which is a double shift. The center of the line is a single component 0, but the center of planar space is a 2-component 1. That changes everything, and that's going to change the neuronal structure of your brain. You're going to evolve, or you're just going to die scientifically, because I got it right and nobody else did. So now we have a circular infinity that's a conjugal number 1 proportion 1. Amazing. So far, can we do anything with that? Nobody yet has ever realized that there's something you can do with that. You can now define the other operator, which is for circular and spherical space, called the proportion operator, which we're taught in school is division and multiplication. That's erroneous. It's the proportion operator. How do we write that? A fraction. So the smallest number is 1 over 1. You will object? You should object. What about 1 over 2? That's smaller. That's inside the circle. To the proportion that 2 over 1 is outside the circle. And that's the end of the bootstrap theorem. We just invented a new number system called fractions. So now we need to prove that those fractions are binary, and that will give the solution to the Einstein field equation, the Einstein energy equation, the collapse of the wave function, and the quantum of gravity. All comes from this one step. That you change number systems to the proportional number system, which reparameterizes the plane, putting Euclid inside the circle where we can just forget about him, because add doesn't work. Add requires 0, 0 doesn't work. The line has been proved to be infinitely dense with irrational numbers. We can't use those, they don't work. You can't have pi. You can't have e. You can't have an irrational number. You can't have the square root of 2. They're not numbers. I discovered that. Incredible breakthrough of insight of evolutionary proportion. So now I'm going to prove to you that we can define infinity now in real space, which means physical space translated directly to geometry, so they're exactly the same thing. What we do in this new number system with this new spherical geometry will be an exact match on reality, solving all of our equations. No more paradoxes. How do we do that? You have to do what no man has been able to do, or has been afraid, or too stupid, or however you phrase it. You have to define infinity, or you lose half of reality. So we found out through the past few lectures that infinity has an extraordinary characteristic called imaginarity, the most powerful term ever composed in mathematical physics, is the concept of imaginarity, because it's real, implying a contradiction. It's not a contradiction, it's that your mind is finite, and now you're going to extend your mind into infinity. That's what it means to rationalize infinity. You will see it for the first time in human history. Here's how. When you have the circle, beyond which is infinity, which is imaginary space. So now we have the universe, outside of which is something that's called imaginary space. And now we're going to rationalize that so that it's real. It's not imaginary. That's the trick, is to rationalize imaginarity. Can that be done? Here's how. When you follow the bootstrap theorem as I just taught you, the line that you draw to the polar infinity defines the circle, which is the edge of circular space. Now, this is the circle which represents the sphere on a constant relationship. So when I say circle, everything I say about the circle applies to volume space when it's spherical volume space, which is the correct geometry, not Euclidean, not linear, and not linear numbers, which has zero and irrational numbers, both of which destroy the system for physical space analysis, as has been amply demonstrated for the past 100 years of perfect stagnation. When we should have achieved the result by now, I got it. So now we have infinity, which is imaginary space, outside the real universe. So space is inside the circle. Okay, that makes sense. I know you're following this so far. When you have the circle, which is the edge of the universe for this geometric space, outside is imaginary, inside is real. The circle itself conjugates those two spaces, one of which is imaginary, one of which is real. That defines a complex number system. We're not going to use that because the complex number system is a mistake, because it's irrational at every level. It's extremely powerful in linear analysis. So complex numbers are used to attack the quantum paradox. That is unsuccessful so far, and I discovered the reason why. You're using the wrong number system. So when you switch from one component additive space on the line, and now you realize that there is a second larger space called the circularly parameterized plane, the circle is defined on a new number system which has two components in rational relationship, the center of which, the Archimedean of circular space, is 1 proportion 1, which implies a crazy notion that there's nothing inside the circle. Incorrect. You made the same mistake that Euclid, Einstein, Feynman, and everybody has made. Let me correct you. The inside of the circle is real to the same proportion that the outside of the universe is real. And now you realize we're talking about two different circles. The circle at the edge of the universe and another circle which is the center of this geometric system we're calling the circular universe. So there are two circles. The center, inside of which is imaginary space, and the outer circle, outside of which is imaginary space. That should set up a geometric relationship in your mind. I solved this. It's called conjugality. And that is proportionality. And that's the definition of multiplication and division and the fractions, all of which are two proportional number spaces. So we now have a parameterization of the plane where we can say the circle is one number, but it's a two-component number, which you would say is 1 over 1. That is a correct notational representation as long as you realize that 1 over 1 does not imply division. Which is why I recommend, although I don't expect anybody to follow this, you should write that as 1:1. And the colon is the operator between the two ones. And that produces the circle, the perfect rate. That invokes the notion of time, which we're getting to. But time only occurs in spheric space. You can pretend to put time on a circle, which we're going to do to solve the Einstein field equation, but that's a little ahead of us. First, we need to get the bootstrap theorem so we get the definition of infinity. Here's the definition of infinity now that we've reparameterized the plane and put Euclid inside, where we don't have to think about him. He's now in imaginary space, because that line inside the circle is imaginary. And all lines are imaginary. But as long as they're drawn inside the circle, Euclidean mathematics is consistent for add, but not for any other operator. Multiply and divide do not work on the line, they work on the circle. So here is how you can prove that. When you have the circle at the outside of the universe, it has a value of 1 proportion 1, correct? Yes. What about going in towards the center? Can you reach 0? There is no 0. but there is on the line. So we know it's there in the subspace called the linear space. So that's going to be the center of this circle. Is coincident with Euclidean 0 for the line. Now, in planar space, it has to be a double 0. So we could say that the center is double 0. And it's imaginary, as of course it is. But it also has a dimension. There's a dimension to 0. And that should remind you of the black hole. We're going to define that for the first time in the history of astrophysics. So we have a lot ahead of us, which I've covered for 4 years, but nobody has been listening to my videos, so I'm making one video to encapsulate everything, beginning with the breakthrough discovery of the conjugation of the two spherical infinities. So outside the outer circle is the outer infinity. Inside the inner circle is the inner infinity. And in between the center of this circular universe and the edge of this circular universe is actual space. Much more closely allied with physical reality than Euclid or lines could ever be, because it's just a fucking scaffolding. It's a bunch of grid. Making squares and cubes. What are you, monkeys? The universe is spherical, and we need to do computations on a circularized plane, or you're not going to understand these conundrums in upper echelon physics. The answers we all want. I've got them, but you have to get this first, or you don't even have the language to dissolve the paradoxes and get the solutions you want. So here's how you do it to get to two-component space. That is technically called multiplicative space, but now you know that's ridiculous. Of course it's not. It's proportional space. Proportional. What does that mean? There's a relationship between the numerator and the denominator. That is not obvious when you define the rational numbers incorrectly, which has been done forever. The rational numbers are numbers that can be written as a fraction with two whole numbers, is most often said. So you have something like 1 over 3 or 3 over 2. Those are rational. Well, 1 over 3 is not rational, so that's incorrect. So you have to reduce the number set from the infinitely irrational single component number set of the line, which was proved by John Horton Conway, which I proved that he proved it because he didn't know he proved it. So I'm a genius even beyond that of my teachers. So you're really tuned in at the right moment to get everything you need to understand physics or mathematics or reality. So now we have two circles, one of which is the tiniest circle you can draw, inside of which is just imaginary. That's the quantum of this space. So the quantum circle is at the center. It has a surface, but it has no interior, unless you're willing to say it has an imaginary interior, which you're forced to do if you want to retain linear algebra in this system, because it's somewhere, actually not just somewhere, but at the center of that smallest circle that you can have is 0, 0 in imaginary space, and that's actually a partial solution. So we're on the right track. Can we conjugate infinity? Yeah, we just discovered one. Inner infinity in circular space. There's an inner infinity inside the quantum circle. The inside of the quantum circle is imaginary infinity. At the edge, the other circle that bounds universal space, outside of which is imaginary infinity again, but it's conjugal opposite to the inner infinity. They multiply to 1. The center of the inner circle has a linear mathematic value of 0, 0, but actually it's purely imaginary space, so it should just have one value. It does. 1 over infinity, to the proportion that outside the outer edge is infinity over 1. Infinity over 1 is the two-component number form for circular infinity going out. That's conjugal with circular infinity going in. And you have to stop at the edge because inside the inner circle is imaginary. There aren't any numbers in there. And outside the outer circle is imaginary. There are no more numbers out there. The highest number possible is the surface, and that's 1 proportion 1. The smallest number going in is also 1 proportion 1. So these two circles are called symmetrical in circular space. They're actually orthogonal on infinity, and now I'll prove that to you. If you say, as we're going to say as our hypothetical step in the bootstrap sequence, if you say that the value of the interior of the infinitesimal is 1 over infinity, you can make that work if you say simultaneously that the outside of the circular real universe, spatial universe, is imaginary infinity, but it's infinity over 1 because it's positive, it's going out, so it's a whole number. It's infinity over 1, which is a conjugation of unity and infinity. The same thing occurs inside the quantum. The definition of the quantum space, which is the inside of the BB, the inside of the smallest physical thing, is also a circle. It's a quantum circle. The outside of the universe is an anti-quantum circle because it's the opposite of what is a quantum. It's the largest of space, is the outer circle. The smallest of space is the inner circle. Those multiply to 1. Both the surface, which is 1 proportion 1, and the outer surface, which is also 1 proportion 1, but inverted. It's not 1 over 1, you flip the two 1s. And so it's not 1 over 1, it's 1 over 1. And that's a completely different thing because it's non-commutative. So you've changed the commutativity of the two-component 1. And that gives you the option to conjugate the infinities. 1 over infinity times infinity over 1 equals one of those surfaces. And if you say it in one order, where it's infinity over 1 starting at the outside times 1 over infinity, that is a non-commutative multiplication. It yields the same numeric result, 1 proportion 1, because 1 over infinity written as the first variable, that is the first number plugged into the two componency conjugation, you need two numbers. They have to be computable numbers, which means they're linear, linearizable. So you have 1 proportion 1 as the surface of the quantum of space. So inside the quantum surface is the quantum of space, which has a value, 1 over infinity. The smallest number you can write, which is half imaginary. It's the conjugation of imaginarity with unity. The opposite conjugation of imaginarity with unity occurs at the outer surface, the outer circle, outside of which is infinity over 1. If you choose that as the first variable, as the number for the first variable, then it's infinity over 1 times 1 over infinity. That's a specific order which is non-commutative, and I'm going to show that to you now. If you do that, you get 1 proportion 1. But it's the largest 1 proportion 1. A proportion does not necessarily denote a specific quantity. It denotes the specific relationship between two quantities. And we're going to find out what those two quantities are in a moment, but first we have to know that there are two quantities, only one of which can be space. So that's miraculous because that matches partially what Einstein discovered. So we found that there's an imaginary space outside the universe that's conjugal with the imaginary space inside the universe. That's what we just proved. It multiplies to unity. And the largest version of 1 proportion 1, using the two maximal values of the denominator and numerator, it may be 3 billion trillion trillion over 3 billion billion trillion. But that still reduces to 1 over 1. When you go in and you counter the quantum, the inner surface of reality, inside of which is imaginary space, that's the quantum, that's a definition of the quantum, that produces the paradox, of course, but inverted. It's actually reciprocal. So you're getting smaller and smaller and smaller with your numbers. So it's not 3 billion over 3 billion. It's now getting close to like 2 over 2. That's the unit circle outside the one. It's just the same circle with the same proportion, but contracting. It has to stop before 0 because 0 is an imaginary space. We just proved that. So it stops at 1 proportion 1, of course, because all circles have that value. All circles have the value 1 proportion 1. But that proportion does not denote the linear components, which could be 2 proportion 2. It could be a billion proportion a billion. But it still reduces to 1 proportion 1. So those are simply equivalent ways of writing in 2 component number system space a 1. That is a 1 proportion 1. It has an infinite number of representations in linear terms, changing the denominator and the numerator so that they're always in sync. So it's always 1-to-1 relationship. That's the rate of the circle, which involves time. And so now we can conjugate time in there and get the correct solution to the Einstein field equation for spacetime, so that it uses time in its right space. He linearized time, which is a hideous error, but I don't want to be saying it in a negative way, because Einstein discovered the orthogonality of time with space, which has been proved. So how is time orthogonal with space? It's orthogonal in the spheric system, and I'll show that to you now. Because there's a surface at the quantum limit going in, the infinitesimal 1-1, and there's another reciprocal 1-1 at the outer edge. One's the maximum 1-1, which forms the edge of the universe, inside of which is real space, and outside of which is anti-space, that is, conjugal space. It's perpendicular to the interior. If you go out from the surface of the circle, or you go in from the surface of the circle, going out it gets bigger on the circular relationship. It's getting bigger as a circle. If you go in from the same circle, it gets smaller. And the way that the two numbers change is not linear. The numbers going out double in a binary projection, which is correct. And so we're going to introduce the binary number system now, because that's the computable number set for spherical space, is the binary number set, which is a 2-component number system based on powers of 2. That's a major insight for which I probably deserve a Nobel Prize. But Nobel Prizes aren't given out to people like me, so that's just a fatuous dream I just mentioned to you because my personality is involved here. Yes, I can't avoid it. I don't say that I deserve credit. I'm just saying it would be nice to be listened to since I have the right answers and nobody seems to care. Well, that's because of me, obviously, as I'm at fault and I must be a monster. Sorry, that is too late to be doing that, either myself or projecting it in any direction. So now you know that the outside of the universe is identical to the inside of the universe, and that defines the quantum, and that defines infinity. So the 2 conjugal infinities, which is exactly what we wanted to get, are now well in hand. If you have 1 over infinity as the interior of the infinitesimal, that's an imaginary interior, to the proportion that infinity over 1 is imaginary space outside the circle. Okay, those 2 circles are the same and they overlap. So the quantum surface, 1 proportion 1, is identical with the limit of spatial infinity. So the inner limit and the outer limit multiply to unity everywhere in the universe. So this is the universal constancy that's implicit in 2-component space. So now we have the conjugation of 2 infinities that produces unity. I hope you consider that to be profound. I'm very happy to be able to make that statement. So what can we do with it? We now have the ability to parameterize physical space with real numbers. And when I say real, I mean binary numbers. The universe uses binary numbers. They're proportional numbers. They have to be, or you can't you can't have a mathematical system for the plane, but now we do have a mathematical system for the plane. It does not have a zero. That's an imaginary space. It's actually the derivative, the 0, 0 center of the inner circle, which we can see is there. It is definitely on the diameter, and so that diameter has a value of 0. So the two numbers making the xy inside the circle, that's a double 0 at the center. That's the infinitesimal of inner infinity. In linear space, it's the linearization of infinitesimality. So the diameter does not exist. There is no distance inside that circle because it's imaginary space. But we know it's there to the same proportion that we know that there's something outside the edge. They are the same space. So the interior of the smallest sphere in the universe is conjugal with the outer surface. And that invokes the two-force balance system that balances the universe according to Emmy Noether's Nobel Prize-winning discovery of the conservation of symmetry. That is, symmetry has a direct application to the conservation of force. There are only two forces in the universe, centripetal and centrifugal. And those are easily distinguished from one another. One is centripetal, and the other one is centrifugal. So that's a hideous problem. I will have to simply say the two words slowly because there are no synonyms for the two forces that balance the entire universe in binary conjugal spherical space. So the two terms are centri. Both words begin with C-E-N-T-R-I. And I won't say that because that contributes to the lexical problem. So there are two forces in the universe, pedal and fugal. Pedal implies one of the two spheric directions, of which there are only two, going in or going out. I think you see that. I hope so. Think about it. Repeat this video if you have to. It would be no shame to do so. This took me quite a bit of effort to figure out, but now that I can prove it, you deserve to get it straight. Well, I hope I'm doing well. But let's go on. So now we have a finite universe that has a highest rational number. What might that be? Well, whatever it is, it has a reciprocal number, which is the smallest number in the number space. So it is a finite number space. It would have to be because we have a finite universe. So this is so monumentally miraculous. This just solves everything, as you'll come to see, but I hope you're starting to see. This has enormous application, because now we can see physical space mathematically. That had been the goal, but if you use linear numbers, you've taken a chain, you've tied it around your feet, and now you're going to run a marathon. And that's the state of science today. It's a bunch of men wrapped in chains running a 26-mile marathon. They won't get more than a mile before they all die. And that's been happening for several generations now. Just dying like flies. Oh, I have a theory. Oh, I have a better theory. Oh, there's a string. Oh, there's a flux. They don't know what the hell they're talking about. There's a Big Bang. Well, you're out of your mind. The universe is expanding. Oh, of course it is, because you say so, because the government pays you to say that. What is the truth, though? This is the truth. So now we're going to get time into the system. Time naturally fits into a two-component system, because what are these two values? I'm going to show you. We now can find any position in space, not with a coordinate number, which would be x and y, but with a conjugation of the two linear aspects of spherical space, which are in and out. So in and out is not the same as polaric plus and minus. It has a completely different metric based on Zeno's paradox. When you try to extend single component numbers to infinity, you realize that you're just running off a rail. But when you try to compose spherical infinity, By dilating the sphere outward and dilating the sphere inward, you're parameterizing spherical space with spheres. We're translating that to the circle because it's directly commensurate. So a circle has a smallest value. The proportion remains the same because the value of every circle is 1 proportion 1, because it's the perfect rate. And that introduces time. Did you know that light speed is a rate number? It's a 2-component number. It's distance over time. That's a fraction. So if you unitize it right, as is very often done in mathematical physics, you have a value of c of 1. But they never say it right. It's a value of c of 1 proportion 1. It's the ratio of time to space when they're unitized to discrete values. So we do know the proportion when you use the meter and the second. But you don't have to use the meter or the second. What you do have to do is get the ratio between the two in whatever units you choose. Well, what units are you going to choose for distance? What units are you going to choose for time? Well, Einstein formulated a orthogonal solution where, since time can be linearized, in linear relationship to spatial separation. So distance is linearly related to time. If you say it that way, which Einstein did, that's a mistake. You cannot linearize time. Technically speaking, you can't, well, you have to linearize distance because distance is linearity, but time is not. So how did, it works, but it works on conjugality. He actually made time orthogonal to space. Is it? Yes, but only in spherical space. I'll show that to you now. So essentially we have 3 spaces now. We have a certain number of spaces now. We have the infinitesimal space, which is 1 over infinity, which is the number inside of 1, 1. So 1, 1 is the infinitesimal circle. It's also the border of infinite space going out. So 1 proportion 1 is the border of space going in, after which it's imaginary inner space 1 over infinity, to the proportion that going out, you reach the same limit because you run out of numbers with a finite number set, which you have to finitize by measuring the universe, but you can't measure the universe unless you use a 2-component number system. Otherwise, you'll never capture time. That's the conundrum in cosmology right now. It's just nobody can see clearly what they're doing wrong. I can. So this is how to solve that. So now you have spherical space, which we're translating to circular space because they're commensurate on a constant relationship. So whatever I say about the circle applies to the sphere. Now we have a circle, and we need to concentrate on which circle. The infinitesimal circle, which defines the lower limit of actual numbers, and the outer circle, which defines the upper limit of 2-component numbers, both of which end up being proportional 1, 1. But in the upper case, the outer edge, it's some large number over the same large number. What are these 2 quantities? At the inner limit, you have the same thing, except it's the smallest relation. It's actually 1 proportion 1. Whereas the outer circle has like Google proportion Google, which is valid. It's still 1 proportion 1, but it's a much larger denominator and numerator for the linear values. We're approaching the correct definition of light speed. So light speed is defined as one of these numbers. When you use the meter and the second, it's 300 million to 1 meters per second. 300 million to 1. It's 299 million, 492, no wait, 299 million. I had it memorized, but memory is fickle. Anyway, you can round it off because it doesn't matter. is 300 million to 1. That can be inverted, which would be the relationship of time to space, using time in the denominator. Did I get that right? What's on top? I'm slightly dyslexic. So if you have time as the denominator, you have the definition of light speed in meters per second. But if you invert it, you have light speed in seconds per meter, which is obviously the reciprocal. It's 1 over 300 million. So that's the number. That's the number of distance units per second. It's very brief, I think. Well, anyway, you get the idea that they're reciprocal. So light speed is a large number, 300 million to 1, because it's distance over time, which means the number of distance units per a segment of time. In Einsteinian space, it's a distance of time, which is a contradiction. So there's something fishy in the way time is being employed as if it could be linearized. And the reason it works is because the perpendicularity of time with energy, which is what I discovered is the true solution, the perpendicularity of time with energy, they're perpendicular. That's a major discovery as a direct result of my geometry. That it's not time-space, it's energy-space, which are two physical quantities, instead of time, which is an abstraction. And I'll show you why that is such a hard term to define. Einstein assumed that he could linearize it. How he figured this out is anyone's guess, but it does work because the orthogonal relationship between energy and space implies that the derivative of energy, which has a time component in energy, that remains perpendicular on the derivative, which is what Einstein got. He got the derivative solution in linear space for an actual spherical solution, which gives you the physical solution, which is what we actually want, because that's reality, which is then geometricized, which can then be mathematized. And Einstein got it flat wrong. Because you cannot linearize time, it's a component of energy. And I'll show that to you now. Now that we have a circle at each edge of space, that would be a single center for a single universe. And the reason we have so many multiple universe theories and various conjugations of universalities, so that the universe is not just one thing, but it's many worlds or various parallel universes. It's very common. It's almost unavoidable because of the trap, the rat trap, that these poor mathematicians have pushed themselves into. They're just trapped. They don't know what to do, and so they just lash out with numbers because they're getting paid to do so. And so they come up with all these crazy theories, such as the many worlds theory. But why do that? Why try to change the definition of the universe when it's obviously just one thing? It's because there's an anti-universe and everybody can smell it. It's that imaginary space I just showed you. That infinity is that space that nobody can see. And it's at the inner edge, it's called the quantum limit, inside of which is nothing that linear mathematics can observe, and there's no linear geometry that can explain that there's an inner surface to space, inside of which is no space. How can that be? Well, it's because it's a proportionality that has to do with in and out. Where if you go out, you just simply hit spatial infinity and lose your mind. I just showed you that you don't have to. There's a boundary beyond which you can rationalize outer infinity. But when you do that, you discover the number system will not support 0, 0. because every circle is 1 proportion 1. It's the exact rate of something to something, which we call x and y, on a Euclidean plane. So the circle is the perfect rate of time to space. And I'm now going to show that to you. This is a reformulation of Einsteinian geometry, so that it's no longer pseudo-hyperbolic, it's simply spherical, which we can then we have rationalized that. So you don't need the supercalculus, which puts it far beyond the reach of science. It's pure technology, it's not science any longer. It's serving something other than humans. So you could say that Einstein was indirectly a servant of Satan. And you wouldn't want to say that, because if Einstein could hear you, he might be offended. So I don't say that. But it is true objectively. He was not serving science. He was serving technology. He never deviated from that. He was trying to get an atomic bomb to blow up Hitler. He approached Roosevelt, and they say that his letter may have changed the war. He wanted the atomic bomb. He's one of the co-inventors of the atomic weapons system. And the only reason he cared about it is because a whole bunch of people with whom you might say, might have identified, apparently he did, because he was approached by Zionist leadership who begged him, could you please talk to President Roosevelt? We need to blow up Hitler before we're all exterminated. And Einstein, being, I guess in his own mind, affiliated with these Zionists, went to Roosevelt as they asked him, they begged him. And so he did. He wrote a letter to Roosevelt, and the military went into action and started producing Los Alamos and the Trinity experiment, which was too late to affect the war in Europe, but it sure came in handy with Hirohito. So that was the beginning of the atomic age, directly as the result of Einstein's efforts. So he had a certain angle on what he was doing, which is why I say he's not doing science. He was doing politics. Now, he didn't set out to that. I'm not impugning Einstein. He's one of my heroes. But there is this nasty side. Feynman also was a murderer. Anybody who works in weaponry is a murderer. That's a religious principle that you may not agree with. Oh, might makes right. Well, you're just parroting the protocols of the learned elders of Zion, which is what they say on the first page. Might makes right. Morality doesn't do it. You have to suppress morality. Well, he did in order to save the Jews. Well, the Zionists are still doing that. Killing everybody else in order to save themselves because they're important and the others are not. That's the Zionist policy. That's in the Protocols of the Elders of Zion, which is a forgery. It certainly was not written by an insider, but whoever wrote that had an angel looking over his shoulder. So there's the sordid side of the Einstein field equation. It was really the Einstein energy equation that did the job there. E equals mc squared. That killed tens of thousands, uncountable thousands of people in Japan because of Einstein's fucking genius. So what a scientist to lead the children. Yeah, to the Aliyah. Now that we have infinity and imaginarity in hand, we turn to what is arguably the most important concept of all, is continuity. Continuity is the opposite of infinity. Continuity is unbreakable. You can see that infinity breaks into a duality. Continuity does not. Continuity is what it implies. There's no quantization. That's the definition of the circle. It cannot be quantized in linear quantities. It's not quantizable because a circle is a rate. So what's a rate? Well, you might suggest perhaps it's light speed. That's exactly right. That's exactly right. The circle represents light speed. because it's the perfect rate of space to energy. And now I'm going to show that to you. When you have a sphere which has an angular momentum, you now have the eigencircle of the sphere. Those are the circles that we're composing. They're the eigencircles of a sphere. What does eigen mean? It has the integral of angular momentum on that circle, so that one of the values of the circle is that rate, the rate that exists between space and energy. Energy is angular momentum. That is the base unit for energy in the universe, is angular momentum. I discovered that. I just realized. I never realized that before until now, but I did discover that. That it's not that time is orthogonal with space, although in the linear derivative solution, Einstein proves that the spherical orthogonality still holds. So I'm now going to show you what that is. So you'll know what time is, and you'll know that it's a component of energy. So now we have a circle with a rate of what to what. The way to discover how to parameterize the intrinsic geometry of the circle, which I discovered, is you break the circle conjugally. And it's very easy to do. When you have a circle, you have a continuity. It's not a line, and that's the reason it's not a line. A line has to be quantized. A circle cannot be quantized, but in order to have a metric for a circular distance, you have to quantize the two-component space. So you quantize that with binary numbers. And these are the counting numbers of circular space, beginning at 1 over 2, which has a reciprocal 2 over 1. So now you have a circle whose rate is 1, and now you can relativize the inner and outer aspects of circular space based on unity, which is the center of the system. Inside that circle is imaginarity. And outside the reciprocal circle, which is at the edge, is infinity. And those are two perpendicular infinities. And that's why the outer circle is the same as the inner circle, which leaves a strange space in between, which we call the universe. It's the conjugation of two infinities in spheric space, one of which is the quantum, and the other of which is spatial outer infinity. The inner surface of universal space is not spatial. The outside of this circular universe is spatial infinity. But the inside of the quantum circle is something other than space. And they conjugate to make space, because outside is non-spatial, but the inside is also non-spatial. But what's in between, with a finite number set defining all the circles in between outer and inner, that's universal space, which is now a new form of distance. It's spherical distance. So to measure the distance to the edge of the universe, you have to do it with two componency numbers. Otherwise, you cannot define the edge either in or out. But with two component space, they're identical on a reciprocal. So going in, you achieve a limit that you can't break, and going out, you achieve a limit you can't break, and neither limit can be broken until you orthogonalize them, and then they multiply to unity. And that defines the metric of the space. So that when you have a circle, and you are looking at it from the point of view of looking out in, so it's inside your field of view. So it's the small circle. Looking out, you can't see that one. But you know it's there because you can measure it with a finite number set, which has an upper limit, which would actually be the highest frequency. The highest frequency is at the edge, because it's the highest quantum number. is the highest frequency of light. Whatever that may be, and it hasn't been discovered yet. It's beyond the gamma range, but we don't know how far. And the frequency is an extremely large number, which of course is reciprocal to the wavelength. The wavelength is what stops at the inner limit. There's no smaller wavelength than 1. And there is no larger frequency than 1 to that proportion. So the entire universe is a perfect conjugation of frequency and wavelength. Where the component numbers change in the frequency and relationship on an orthogonal relationship. And that should make sense, and that's coming up on an hour. So now I'm going to summarize what we have so far and give you one example to lock this into your head, and then we're going to go on for an indefinite number of video presentations so I can show you the applications of this new geometry, which are nothing short of miraculous. So, we have a new number system called the dyads, and these are powers of 2. So let's do our first computation in spheric space, which we're saying is circular space as an easy projection downward. It's consistent. So we use the circle, but it's always the sphere we mean. So the circle has a surface and an interior and an exterior. There is a geometry that explains the relationship between the interior and the exterior. The interior is imaginary, and the exterior is space. So there's no space inside the quantum of space. And that actually is the quantum of space. It has a proportionality of unity, which is consistent all the way to the edge. So that is the universe as uni. It's a universe. I just proved it. So I just proved the existence of the universe. It is finite, and it's bounded by 2 conjugal infinities, which make an anti-space that is at least as real as the space we think we see. It is the imaginary space that's driving physicists literally stark staring mad. They know it's there. They know it's on the other side of the interior of the black hole. They know it's on the outside of they know it's everywhere. They can't see it, so they're attacking it with complex numbers, which cannot work because it's irrational. I have the first rational number system for physical space. So the quantum is 1. There's a physical manifestation of the quantum of space. The inner limit beyond which inside is no more space, it's something else. That is called the proton. The only particle in the universe is the proton. Nothing else is a particle. Only the proton is. We'll get into that in the next video, but I want to give you the number system in the first example using the dyadic fractions, conveniently for us called the strict binary number system, the powers of 2, where the index, the exponential, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and that's going out toward infinity, out. Reciprocally, you have 1 over 2, 1 over 4, and 1 over 8. ... These are concentric circles going inside. It can't reach 0. There is no 0 in the binary number system, but there is something linear inside the quantum. It's just that it doesn't have a number system. But there is a 0, 0 inside the quantum. That can be proved. Well, you can actually see it. There has to be something inside the circle. There is. Inclusive of all the errors, all the irrationality, and all the skullduggery of linear numbers, which can't really do anything with add. You need the Pythagorean theorem. While you're dead in the water, you're going to end up like Einstein, just composing a giant Pythagorean construction that simply does not do what you want it to do because you're using the wrong reference frame. We just changed from 0, 0 on the plane to 1, 1. And that's the definition of a circle. And that's an hour. So the 1 over 2 that's starting to compose the interior of the universal circle, going from out to in, you can go halfway, 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 right? out until you reach the edge. If you go backwards, you end up with 1 over 1, not a billion over a billion, whatever is the highest frequency. We'll be right back. Keep looking up. This is Anagalactic. Thank you for your patience. There's much more to come. Stay tuned. Thank you.